all of them. Let's see here. So I think essentially the point is, given our definitions, the way this proof has to work is we have to like see our result in view of this implicit definition, right? Which means essentially I need to calculate d bar omega 1, 2 in terms of d omega 1, 2. So how do you get at that? Well, what I did was I calculated let's see here. Let's see. First of all, I found out how the coframe relates to the frame, right? So we're going to focus on the first case. All right, case 1, I'll call it. All right. And so for case 1, we have, let me call these equations star. All right. So case 1, we get star, right? And then the first thing I'll do is calculate theta 1 as it relates to the barred one. So the barred coframe is a basis for covectors at a point. So I can expand this in terms of the coframe basis like follows. That's theta 1 of e bar 1, theta bar 1, plus theta 1 of e bar 2, theta bar 2. So when you look at theta 1 of e bar 1, how do you calculate that? Well, you got to look here, but since e bar 1 is right here, right? When theta 1 hits e bar 1, it is 0 on e2, and it is 1 on e1. So this is just cosine of phi. And theta 1 on e bar 2, it all goes back to the duality, like the definition of theta, how, theta 1 relates to, it goes back to this, right? Theta I ej is what? Kronecker delta ij, right? So when you let theta 1 act on e bar 2 here, the e2 piece doesn't matter, but the theta 1, e1 is 1, so it just picks off a minus sine theta, sine phi rather. And so therefore, theta 1 is cosine phi theta bar 1 minus sine phi theta bar 2. Which I think is what I have written in the notes. Yep. And likewise, similarly, theta 2 is equal to sine, let's see here, theta 2 would be sine phi, I can even read it from up here, sine phi theta bar 1 plus cosine phi theta bar 2. Now, I will say that I think you can gain a deeper appreciation for what we're currently doing if you go back and like mull through that stuff on the J of V and V, where we're talking about the angle between two vectors in the surface, like that. That probably would, that might give you a deeper understanding here. I don't know. But anyway, so theta 1, theta 2. That's how they relate to theta bar 1, theta bar 2. And so, I would invite you to try, you can try it out. Try it out, theta 1 wedge theta 2, what's it equal to? I'm not going to write it out. I'm just going to sketch the calculation. So it's going to give you cosine squared phi theta bar 1 wedge theta bar 2 minus sine squared phi theta bar 2 wedge theta bar 1. So check it out. What does that mean? That's 1, right? Sine squared plus sine squared plus cosine squared. It's not 1, but it is. Like the coefficient is 1, so it's just that, right? I mean, theta bar 1 wedge theta bar 2. Now we're in case 1.
No. Well, it would be 1 if you just switch it, the bars right there.
Yeah, switch this one. That gives me plus sine squared.
Yeah.
Cosine squared plus sine squared is 1, so that.
Oh wait, and we proved that earlier. That theta 1 wedge theta 2 is equal to the bar of theta 1 wedge theta 2.
Well, it is true in the case that they're related as an equation star. Now, if instead of star, if you do what I call E2 prime, which would be putting a minus on the second one, which I illustrated geometrically with this dot, 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 dot E2 thing here. If you did that, that would put minuses on, that would like flip this minus sign to sine, and it would flip that cosine to minus cosine. And that net effect of that would be that theta 1 wedge theta 2 is minus theta bar 1 wedge theta bar 2 in that other case. So anyway. So that's the first thing. That's how the two form related to the coframe basis is related for one orientation versus another. All right, now, then you take exterior derivatives. Like what's d theta 1 equal to? Well, my theta 1 is here, all right? And I'm just gonna do it. Well, it gives me minus sine phi d phi wedge theta bar 1 plus cosine phi d theta bar 1 minus cosine phi d phi wedge theta bar 2 minus sine phi wedge d theta bar 2. So what I've done there is the product rule, right? Because we got a product of things, we have to do the product rule when we take the exterior derivative. Lovely. So and then you can, these guys, by definition, those are related to, let's see here. So we've got minus sine phi d phi wedge theta bar 1 minus cosine phi d phi wedge theta bar 2. And then we got plus cosine phi. D theta bar 1 is what? That is omega bar 1, 2 wedge theta bar 2. And then I've got minus sine phi. I don't really need the wedge there. Minus sine phi times omega bar 2, 1 wedge theta bar 1. By definition of the connection form. But on the flip side of things, this is, of course, omega 1, 2 wedge theta 1, 2 rather.
Is that d phi? Yeah, it's d phi.
Yeah. Let's see here. So I could like factor out the theta bar 1 term, and I would get myself minus sine phi d phi minus sine phi omega bar 2 1 all wedged theta bar 1. And then I could get myself a minus cosine phi d phi plus cosine phi omega bar 1 2 all wedged theta bar 2. I mean, true, but anyway. I hate that we've hit this calculation this time in my lecture, for I am tired.
I'm still copying. So,
Yeah, go for it. It is. All right, let me try to come to terms with my strategy here. I mean, that is the All right, well, that is, in fact, what I wrote in the notes here. We're to the bottom of page 5. And what do I do next? Ooh, okay, so I chose poorly. Well, no, I didn't. Well,
this is not what you got. You got a flip-flop. I'm on page 5, that last line.
yeah, but I think we should go to page 6. Page 6 is, we should move on to page 6 here. I'm about to erase the last line anyway, because page 6 has a, I think, a better path. Yeah, I'm gonna erase the last line. It might be wrong. You might be right. It doesn't matter. I mean, if it's wrong, I'm sorry, but what I do in the next page, which is productive, is to factor out the d phi. So like, try to write something wedge d phi from that. And then what's left over past that was the terms without d phi were like, I'm going to write something wedge omega bar 1 2. And I'm just going to think hard about what to put in here, all right? So wedge d phi. So since I had to flip the theta bar here, see that it's flipping? Theta bar 1 and d phi here?
Yeah,
That makes it a plus sine phi. Theta.
I'm just going to write a line over that word.
Yeah, I think that's plus sine phi theta bar 1. And what's the other one? This one, again, I got a flippity floppity, so I get plus cosine phi theta bar 2. All right? Now, the other two, I'm going to put the omega bar 1 2 last, so that picks up a minus cosine phi, theta bar 2, from this term, and a plus sine phi, theta bar 1 from that term here. Oh, but not because, curses. Notice I've got theta bar 2, 1. So there's another minus from that. Oh, but there's another minus here. It's the case of the three minuses. Okay, so I made an even number of errors. I was okay. And what are these things in the parentheses? Oh, that's theta 2. And what's the other one?
Theta 1. Oh, wait, cosine thing. That would be cosine. No, you gotta flip it. Theta 1.
Is that minus theta 1?
Yeah.
So minus theta 1. Wedge omega bar 1, 2.
That'd be, no. Cosine of phi theta 2 minus cosine theta 1. That'd be theta 2. Be negative theta 2, not theta 1.
But theta 1's up here.
Yeah, but it's sine phi theta 1, not sine phi theta 2.
Oh, did I not pay attention to the order?
Yeah, and then it's cosine phi theta 2.
Oh, I've tricked myself.
Yeah.
So that actually is,
Yeah, because in your notes here it says it's theta 2 minus theta 2 as well.
so that's a theta 2?
Yeah, it's a theta 2, because you should get theta 2, by your notes at least, theta 2 wedge d phi minus theta 2 wedge r omega 1 2, which is what you would get. Yeah, that's the theta 2, for sure.
Which means I've got another error in the line above.
Yeah. And so
that's
you
supposed
have an even number, or you have a
that
odd number.
that's supposed to be minus then.
Yeah, and then you can pull a minus out.
Yeah. And the reason that was minus is
So one in there.
so there's one minus from flipping this. There's the minus that was here already, and then there's also the minus that is required to commute those. So there's three minuses. Three minuses is minus. Okay. Which makes that theta 2. Which makes this omega bar 1, 2 minus d phi wedge theta 2. So that's d theta 1.
Well, then you also go on to say omega 1 2 wedge. Because that's equal to omega 1. Oh yeah, you said it up top. Never mind. Sorry.
Now, this doesn't prove the result yet. What this does is it gives you half of it.
Okay.
So the reason for that is we're taking the wedge product of the thing we're trying to study with theta 1, well, with theta 2 in both cases. So like this is equal to that, right?
Yeah.
So that means that it's possible that omega 1, 2 is equal to omega bar 1, 2 minus d phi. Like it's 50% true from this. But all this does is it shows you that the one components of them match up. Then the other calculation is that, what does the other calculation show?
Likewise,
I'll not do all the details, but
d theta 2 is equal to omega bar 1 2 minus d phi wedge theta 1, which is equal to omega 2 1 wedge theta 1.
so this wedge theta 1, omega bar 1, 2 minus d phi wedge theta 1.
Yes.
And then by the definition,
And then you say hence omega 1 2 is equal to
see, by definition, this gives us omega 2, 1, right?
Mm-hmm.
wedge theta 1 is equal to this. And that should have been 2, 1. Is that 2, 1?
Yeah, it's 2, 1. 2, 1 omega theta. Or wedge theta 1. Second to last line, page 6.
There's a typo in the last line. This I'm pretty sure. See, it's minus omega 1, 2 here, and then it becomes plus omega 1, 2 here. There should be a minus out front from that.
Sine phi theta 2 minus.
So what I'm trying to say is, if you look at that, what I really have is d theta 2 is minus omega bar 1, 2 minus d phi, like that, which is important because this gives us omega 2, 1 wedge theta 1, right, equals to this. And then this is minus omega 1, 2 wedge theta 1 equals to that, which gives us finally omega 1, 2 wedge theta 1 is equal to omega bar 1, 2 minus d phi wedge theta 1. The minus cancel. It should, I have there's a sign error there, sorry. And now, so the first calculation gave us matching 1 components. This calculation gives you that the omega 1, 2 and omega bar 1, 2 minus d phi have matching 2 components.
And you can put it together.
Put it together, we get the dilemma. So, oh, yeah. Here it is. All right. So now we're into lecture 24, but this is like a straight continuation of what we've been doing. Now we can either take a break for a couple minutes right now and start again, or just keep going. What do you guys want to do?
Let me get some food.
Okay. Well, let us take a short break then.